Okay, now third problem is we have to design a number container system. We have to insert or replace a number at a given index in the system. So there is some index on which you have to either insert or replace. Then return the smallest index for the given number in the system, where the number has occurred at smallest index. Okay, so there are three types of queries we need to support. It was a data structure design question, that how you can use some built-in data structure or design your own data structure to support these operations to be efficient. Now, first of all, if we try to kind of look at what is it that we essentially need to do, we need to have some sort of storage. This is some sort of storage that we are designing, in which we have to have a function insert or replace at a given index. So that means you have to, the function name given, operation name given here was change. So you are given an index and you are given a value. That means go to that index, put this value. If you just think of this option, go to an index and update the value, what data structures come to your mind that support this operation? At any index, you are going and changing the value. Yes, map supports that. In map, it's index is your key and this is your value. So we know array supports it, call it array or dynamic array, and map supports this kind of operation. If it was just change operation, this too would have been sufficient. Now the twist was the second operation also that we have to support. It is asking you how to find, you have to return the smallest index for a given number, because one number can be inserted at multiple indices. Then you have to tell what is the smallest index at which that number is located. For example, if I take a map or an array, if we take this, if I say this is 0, 1, 2, 3, 4, 5. Initially, if I say go to index 3 and store 10, if that is stored. Now, if I query find 10, what is the smallest index at which 10 is located? Yeah, it is located at 3. We can give that answer. Now, if the second query, I give you a find query and say, tell me where 5 is located. What is the smallest index where 5 is located? We'll give -1 because 5 is not at all located. Now, if I go and give another change operation and I say, go and change index 1 with 10. So you have stored 10 once again at index 1. Now, what is the smallest index at which 10 is located? 1. So 10 is located at 1 also, 3 also. We have to find the smallest index. So now the challenge is each number can be at multiple indices, and we have to find the smallest one, smallest index for that. Now what can we do? So this is very clear. Index to number mapping we can store in an array or map. But how will you support the reverse operation, where when somebody asks you, tell me where 10 is stored and find the smallest index of that? Now, if we take simple array or map, only option we have is to do a linear search. Can we do binary search in this case? Can we somehow do a binary search in this array after a few change operations? Will binary search be possible? If I say go and change at index 2, go and put 15. At index 4, go and change it to 13. Can we do a binary search on this for finding first occurrence index of 10? No. Currently in this form, no, because it is not a sorted array. If it was a sorted array, binary search would have been the option. But only simple array would not support that. And we can't loop over every element because the constraints here are again, the index can be 1 to 10 to the power 9. So array is out of question. Okay, because of the constraints being high, we cannot use array at all. We have to use map, and now going over every key and value of the map could be an overkill if numbers are huge. For every find query, we cannot iterate on every index. Okay, so if 10 is stored at multiple indices, can we store all the indices at which 10 is stored? Can we maintain that? Yes. So two choices we have. Can we have a number and smallest index mapping? That is first question. Or can we have number and all index mapping? See, we have to answer query of smallest index. If we think of first, when 10 was stored at index 3, I could have stored, hey, 10 smallest index is 3. When then 10 is stored at index 1, I can go and say, hey, now 10 is stored at index 1. If I just store the mapping of number with smallest index, will that be sufficient for us to have one more map, number and its smallest index? Will that suffice? That will not suffice. Yeah, it will fail in which case?
When we change the 10 at the smallest index.
Awesome. Yes. So now after this, if I go and say change at index 1, put 15. Now index 1 is gone, but we don't have a way to update 10 back to 3. So one index storing is not going to be sufficient. So this option is ruled out. Can we store all the indices where the number is stored? Yes. Okay. So 10 is stored. Earlier 10 was stored at 3. Then 10 was stored at 1. Then 15 was stored at 2. Then 13 was stored at 4. If this kind of mapping we maintain, for every key, we are storing multiple values. So we will need a map of every value with a list of its indices, right? Yeah, map of list of indices. Now in the list, you have to find the smallest value. That will be time taking. In place of list, can we think of some data structure which can give us the smallest value faster? Yeah, so basically one thing that we are talking about in generic terms, if we talk about, we are talking about sorted set. Yeah, which is preset, or in C++, the built-in set is directly a sorted set. Or in place of that, what if we use priority queue? Which priority queue? Min priority queue or max priority queue? Min priority queue. Yeah, if we use min priority queue or sorted set, we can find the smallest value in the set easily. Is that right? So our find query got simplified. Now, when you are finding the minimum index of a number, you will go to the map, you will give that number, and correspondingly, you will get set or a min priority queue. If min priority queue size or set size is 0, what will you return? We will return -1, absolutely. But if we find some size from min priority queue, what operation will we perform so that we can return the index? Let's say min priority queue has few numbers. We'll be reporting whatever is the top value, and we don't have to remove it. Okay, so find operation is simplified. Find operation is simple thing is get min PQ for given number. And here we are talking about, we are maintaining a map of int comma priority queue of int. These are indices, call it min PQ. We can give a meaningful name to this. Okay, once you get that, if size of min PQ, first of all, you can say if map doesn't have number as key, return -1. Same way, if min PQ.size is 0 in map, then also return -1. Otherwise, get the min PQ, return min PQ.front value without removing it. Okay, so this supports find operation. Now, what is the time complexity of this find operation? In map, we are checking a key is there or not. Yeah, we have two types of map, hash table or hash map. So worst case, it will be log n or big O of 1. Now, min PQ.size is big O of 1 operation. Getting the value from the front of min PQ is big O of 1 operation. So worst case, we can make this function as log n function. That too, when we are using a map, which is kind of a BST map, not a hash table map. Okay, so find operation is log n, which is good enough. Now coming to change operation.
Sir, I guess for min PQ, there is one problem. Like we have 10 at two places, like 1 and 3,
Correct.
third index. So when we update 10 at third index, then we won't be like able to remove it from the min PQ.
Awesome. Very valid point.
So
Set
yeah,
will,
this was the point where I got like
okay.
wrong.
Set will not trouble you in that case.
Yeah, we can easily remove it
Yes.
from
Okay.
set.
One point that Madhusudan is bringing, we will talk about it when we talk about other operations. One point Madhusudan is saying is, hey, if somebody comes and overwrites an index, for example, if somebody comes and says, hey, in place of 10 now write 12. If you are doing this operation, then what has to be done? In this min priority queue, we have to, in list of 10, we have to remove 1. Do we all agree? 1 has to go away. Yeah, so the point Madhusudan is bringing is, imagine in place of 1, if it was some other index, priority queue does not allow us to do a random deletion. This is a problem if you use min PQ, but we will talk about how we can get around this problem. We have done this earlier in other problems. We will still talk about how priority queue can be used. But in case of set always provides us a function. You can go and remove a value from the set. Yeah, Madhusudan is talking about, yeah, we can do lazy deletion in min PQ. Okay, so if it was set, in set we have delete function. In heap, we do not have random delete function. We cannot say, hey, this value from heap should be removed. We always remove the top value or the front value. Okay. Yeah. So let's come to change function. We are going and updating an index and changing the value at that index. So for example, if you are replacing 10 with 12, then our data structure also has to be changed. So if we talk about the state of our data structure, so for now we will say, let me just get rid of these. We have 10 stored at index 3 and 1. We have 15 stored at index 2, redrawing it, 13 stored at index 4. This is what we have right now. Now, if somebody comes and says, let's say we put 19 at index, 15 at index 0. Let me do that. 15 is stored at index 0 also, I'm putting it here. Now, next operation we are saying is change index 1 with the value 12. If we are doing this operation, this is index, this is value. That means 10 should be replaced with value 12. So what operation has to happen? Because what has to happen now? Ten is going to be removed from index 1. If 10 is going to be removed, then should this 1 belong here? Yeah, so this 1 should be removed from here, and this map, this is our map, should be overwritten at index 1. We should have 12. Two changes have to happen. Now, this is where the contention is, that if we have to remove this 1, set supports this operation, priority queue doesn't. So if we are using priority queue, what we will do is we will not delete this index from here. We will let it be here. If it was a priority queue, all we will do is we will go and update our map at index 1, you put 12. And what will happen? Here you will add 12 to this, and you will say 12 is at index 1. Fair? So that means we have one invalid value available in priority queue, but we are leaving it as it is. Next, somebody asks, give me the minimum index where 10 is stored. What answer will we get? Minimum index at which 10 is stored, we will get 1. One additional thing we will do here is we will go to index 1 and check, do we really have the value 10 here? At index 1, we don't have the value 10. So what should we do? We should remove now. Get rid of it. Now ask again. So kind of this will become a loop. When you are trying to find the minimum index of any value, you will be writing the loop. So your removals from the min priority queue will happen here. This approach is called lazy deletion, that we are deleting only when we are using the value. And we have used similar trick in which problem? We did one problem in sliding window where we used the same trick, that we are deleting lazily. Yeah, so it is basically maximum element in every window. When we discussed priority queue solution, we were doing lazy deletion. Yeah. Okay, so conclusion wise, we are using this and we are using map of int comma int. This is index to value map. So, and second option that we had was, this was, okay, value to min PQ map. And in place of this, we discussed we can use value to set map. So choice is ours. And this is sorted set. From this set, you always have to return the first value. So any solution, two maps will help you solve the problem. Okay, now how many of you feel comfortable? If you have not solved this problem, that after this discussion, you can go and solve this problem easily. Yeah, or everyone solved this problem. Yeah, did everyone solve this problem during contest? Okay, Harsha solved. Harsha, which approach you used? Set or map?
I used map.
Okay.
Sandeep.
Map of set or map of priority?
Yeah, map of set. Yeah.
Okay, map of set. Okay, Kumar, you use map of set or map of priority queue? Okay, tree set, sorted set. Cool. Yeah, you can submit one more solution with priority queue in case you would like to do that. Okay, did anyone use any other approach apart from these? No? Okay, then let's move forward to the last problem.